Good morning, everyone. My name is Daijun Ding, and today I will briefly explain what I learned in week 10 of software engineering and how I can link this knowledge to our software engineering project. The week's topic was implementation. Implementation means transforming the detailed software design into a working program. Before this stage, we usually have requirements, architecture, and design. During implementation, we convert those ideas into actual code. However, the lecturer explained that implementation is not only about coding, it also includes unit testing, debugging, configuration management, and sometimes improving the detailed design while writing the program. The first important thing I learned is the meaning of a good software implementation. A good implementation should have readability, maintainability, performance, traceability, correctness, and completeness. Readability means the code should be easy to understand. For example, variable names and method names should clearly describe their purpose. Maintainability means the code should be easy to update or fix later. This is very important because software usually changes over time. Performance means the system should run efficiently, but we should not sacrifice correctness or readability just to make the code faster. Traceability means the code should connect back to the requirements and design. Correctness means the system should work properly, and completeness means all required functions should be implemented. The second thing I learned is the importance of coding guidelines. Coding guidelines help a development team to write code in a consistent style. They can include rules for indentation, formatting, file naming, variable naming, and which language features should be used or avoided. A team project. This is very useful because different team members can have different coding habits. If everyone follows the same coding rules, the final system will become easier to read and maintain. The third thing I learned is about comments. Comments can explain the code, summarize the purpose of a section, mark important areas, or describe the intent behind the code. However, comments should be kept up to date. If the code changes but the comments remains old, the comments can confuse other developers. Therefore, comments should support the code, not replace clear coding. The fourth important topic was debugging. Debugging means locating and fixing errors in the code. The lecturer explained four phases of debugging: stabilization, localization, correction, and verification. Stabilization means reproducing the error using test cases. Localization means finding the section of code that causes the error. Corrections means changing the code to fix the issues. Verification means checking that the error has been fixed and that the fix has not created new problems. We also learned about assertions, including preconditions and postconditions. A precondition is something that must be true before a module works correctly. A postcondition is something that should be true after the module has worked. Assertions are executable checks that help detect when assumptions in the program are not met. Another important topic was performance optimization. The lecturer explained that performance should be measured before optimization. Programmers should use tools such as profilers to find where the program spends most of its time. This is important because optimization without measurement can waste time or make the code harder to understand. Finally, I learned about refactoring and bad smells. Bad smells are signs that the code structure may need improvement. Examples include duplicated code, long methods, large classes, switch statements, feature envy, and intimacy between classes. Refactoring techniques such as extract method, move method, substitute algorithm, and extract class can help improve code structure without changing the system behavior. I can link this week's topic directly to our software engineering project. In our project, we need to make sure our implementation follows the system design and requirements. We should use clear naming convention, consistent formatting, and relatable or readable code. We should also divide long methods into smaller methods and avoid duplicated code. During testing, we should use debugging steps to reproduce errors, locate the problem, correct it and verify the fix. We can also use refactoring to improve our code before final submissions. In conclusion, Week 10 helped me understand that implementation is not just about making the program work, it is about writing code that is correct, complete, readable, maintainable, and connected to the system design. These skills are very important for our software engineering project because they help us produce a better quality final system. Thank you very much.